Alright, so in this lesson we're looking at conic sections. So what is a conic section? So if you can see these diagrams here, I have these cones here. You can see these double napped cones. There's one which is like facing down, and the other one which is facing up. So I have these cones here. Yeah, if you can see those. Yeah. So now a conic section is an intersection between a plane and a cone. So you can see that there are cones here and there's a plane. So when they intersect, they will form what we call a conic section. Now, when these planes intersect with that cone, they will form different shapes. They can form different shapes. So this is what we'll first look at in our introduction. So we are seeing here. I'll start with a circle. So here of a circle. So we can see that this plane here intersects or cuts this conic section in this horizontal direction. So when it cuts it like that in a horizontal direction, we see that here this intersection that is formed there is a circle. So if you are to invert this and write it to look something like this, to be round. So yeah, pardon my words, is my circle. It's just a sketch. So to be round, to be a circle like that. So that is the shape that is formed. So this is when it is perpendicular to the rotation of axis. So the rotation of axis would come in this way, in this straight way, coming here until it cuts there in between. Yeah. So when our plane cuts perpendicular like that at 90 degree to that rotation of axis, it will form this conic section called a circle. Then in a case where this plane uh, cuts at an angle, so we see here, when we look at here, we have this funny name here called ellipse. So an ellipse is just a shape that is formed when when a plane cuts a cone in this way at an angle. So it's more of a stretched out circle. So stretched out circle, something like this. Yeah, stretched out what circle. It will look something like this. So it can be, somebody can describe it as the shape of an oval or so. Yeah. So it will be a stretched outward circle. When it cuts at an angle to the rotation of axis, it will form that shape there. Then we see that in the first part here we have a parabola. So now, if you are here, you must have done either math math 1100 or 1120 or 1110. Yeah, so you must have done those. And we drew funny shapes, like he drew a shape that is of a similar shape as this when it came to that course. So this shape is of a sort, like, yeah, it looks like this, something like this. This is a parabola. So this parabola is formed when this plane uh, cuts the cone uh, in such a way that that plane, the line, so where the plane cuts, it has to be parallel with this side, with the side of of the cone. So if it cuts in that way, then it will form this shape called a parabola. Yeah, it forms that shape called a parabola. Then when we look at the end here, you have what you call an hyperbola or an hyperbola. So an hyperbola has these two shapes here. So one faces down like this, then the other faces up like this. Yeah, up like this. So this is formed. So we have two, as we said in the beginning, there are two uh, cones, like two cones. Then so this plane has to cut one on top and the other down at the sides like this, as you can see in this picture. When it cuts in that way, then it will form what? It will form this shape called a hyperbola. To form this shape called what? Hyperbola. So these are the conic sections that we'll look at in this in this course, or in this part of the analytical geometry. So as you know, the first part of this course is analytical geometry. Then the second part will be what? To be calculus. So in the analytical geometry, we'll be looking how an algebraic equation can describe these shapes that we've looked at here. How it can describe the parabola, the circle, the ellipse, and the what? Hyperbola. So we can have what? As I have said, like the 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 equation. So an equation can describe what? All this, or an equation is used in order to what? To describe these are conic sections. So the general form of the equation. So okay, so it's written circle here, but I'll just write the general form here. So the general form is this. So ax squared plus bxy plus cyx plus dy, or dx can be just the same thing, or ex here follows, then plus f is equal to what? 0. So this is the general form. The general form of what? Of the general form of the equation which describes the conic what? Sections. Can we all see this equation here? I just get a response. All right, thank you. So this is what we will use. We will learn how each shape that we've drawn there, with just an equation, we can find out that, oh, this is a circle, no, it's a parabola, or it's a hyperbola, or it's a what? It's an ellipse, just from the what? From the equation. So this is the general form of the equation. Now we'll move on. As you've seen on top here, it's written what? Circle. It's written the circle. So in this video, we'll just look at the circle. Just look at the circle. I will erase this part of the equation. Yeah, I erase this part just as I will be doing my explanation. So now, what is a circle? So I'm sure we've all seen a circle before. I'll draw a rough circle here. Okay, that was so off. Let me rub this part. Okay, and join here. Alright, so this is my rough sketch of a circle here. Yeah, it looks more of an ellipse, but it's a circle. So we have a circle here, which is just a round shape, round shape like that. So a circle can be defined as a set of all points that are what? Equidistant from uh, one point called the center. So if I say here is my point, or this is my center, then this circle is formed by points that are of equal distance from this midpoint, which is the center. So meaning if I measure from here to there, and if I measure from here to there, it has to be the same distance. That's what I mean. So from any point from the center until you reach the circumference of this circle, it's going to be the same distance. That's what equidistance means. It will give me the same distance everywhere. Yeah, so that's basically what a circle is, if you'd want to define the circle. So now we will say that this midpoint, which we've said here, this midpoint, or this point which we'll call it the center. So the center is going to be given by the points h comma k, h comma k. So let's say we give them by h comma what, comma k. So now remember, we can draw this on the what, on the xy plane, the xy plane. This same circle can be what, can be drawn. So the h, that which we've written, h k, the h comma k, these points are the same, having x and what, and y, uh, x and y, like x and y coordinates on the what, on the xy plane. Yeah, so that will call our center. So if this is our center, then from the center to any point, the distance that is there, distance from the center to reaching any point on the circumference will be r, which is what, our radius. R, which is what, our radius. So we are saying, when we move from the center going to any point, this distance that I have moved from there to any point on the circumference is going to be what, my r, my radius. Yeah, and I think we all know that. So now that point on the what, on the circumference, I will name it x, y, because it's just the what, it's just a coordinate, it's just any coordinate. You can describe this in form of what, of a coordinate. You can say, let's say maybe your x is 1, yeah, is 1, and your y is what, is 2. So you can locate that on the what, on the xy plane, and if that even falls in the circumference, then we are saying that forms the what, part of the circumference of that what, of that circle. So we want to come up now, first of all, before we continue with our discussion, we must generate what, a general form of the equation. So now we've moved to like the circle. We're talking of the circle, so we must come up with a general form of the equation of what, of a circle. The equation of what, of a circle. Since we've said from that general equation that we wrote, we've said that we can come up with, we can be able to identify from the equation whether it's, the shape is a circle, an ellipse, a hyperbola, or a parabola. Then, so from there as well, we'll be able to describe, from what we've drawn here, we'll be able to describe the general form of what, of the equation of what, of a circle, how you would, what you would see. So we'll use the distance formula. Use the distance formula. So let me just erase here and write this properly. Okay, and write this properly. Okay, so let me write it here first, on top, here on the side. Alright, so from my center, which I've said there, so my center, as I said, h comma k, then my point on the circumference is x comma y. Alright, then my distance there, or yeah, my distance there is what, is r. So moving from the center to that point, r there. So now I need to find the what, the distance r. How do I find the distance r? We'll use the what, the the formula of what, of distance of a line. So from distance of a line, I know that I'll have 2 points. So if you can see my center here, these will be my what, my x1 and y1 points. Then these here, this will be my what, my x2 and my x2 and my y2, my x2 and my y2. Okay, so how will I then do this? So I know that r, so we say r, which is distance, in this case our distance. The equation is root, okay, root of, so we say you subtract your y2. So your y2 in this case, your x2, I mean x2 is what, is x, so you put your x there, then minus your y, your x, okay, your x2 is what, your x1, I mean, is h. So that would be h there, then this is squared. So that's why we said you must have that as a what, as a, you must have math versus 1110 and 1100 as a prerequisite, so you already know these things. So here, how do we get the second part? So my y2 in this case is y, so I'll write here y minus my y1 is what, is k. So that, yeah, I have my k minus k, then I'll square this. So this is what uh, my circle is going to be what, to be defined. So this is what my circle will be what, to be defined by. So I can square both sides to get what, to get an equation for my. So if I square both sides, if I square here like that, and I square this as well, you see that we have r squared is equal to, so this square and that will cancel like that. Then I'll have x minus h squared plus y minus k squared. So this is the general form of what, of the equation of what, of a circle. So whenever you see something like this, then you know and identify that it's what, it's a circle. Something that just looks like this to be the circle. So if you can see here on the first part, here like this, you have that x minus h squared. Then on the second part you have y minus what, minus k. So from here you can identify this to be what, your center. Like when you're finding your center, so you would equate this part to what, to 0. So when you equate that to 0, you have x minus h is equal to what, to 0, meaning your x will be equal to what, to h. So your x equal to h just means that your coordinate at the center there is what, is h. Your x coordinate at the center is what, is h. Then when you equate the other part as well to 0, you have y equal to what, to k, meaning that your y coordinate at the center there is what, is k, meaning the center is described by h comma what, comma k, that is our center, and our radius you already have here, that will be what, our radius. Yeah. So at this point, is there any question like what's driving this, as we are now going to look at an example? Okay, I'm not getting any response. I guess there's no question. So we'll move on. So we have this example here. So the example says, find the equation of a circle with given center and radius and sketch it. So find the equation of the circle with a given center and radius and sketch it. So we have been given center. So we have center there, what, in the first part, center 0, 1 and radius 1. Center 0, 1 and radius 1. So how are we going to do that? So meaning, if we were to write there the general form, we said h comma k. So we already have this form, h comma what, k, which is this here, which is 1 comma what, comma 0. So the general form that we had driven is x minus h squared plus y minus k squared is equal to what, r squared. So what does this then mean? So here I have my what, my h. I can identify my h. So my h is what, is 1. My h is 1. So this will be minus 1 squared. Then plus y minus what, my k is what, 0. So that will give me 0 here, like that. Squared is equal to, what is my r? My r is just what, 1. 1 squared is still going to be 1. Yeah. So what do I do from here? So I can expand this. Since they're asking me to find the equation of what? It says find the equation of the circle. So I can expand this. So when I expand this, I will get x squared here minus 2x plus 1, and this is 0, so meaning I only have y squared here plus y squared is equal to 1. So this is the equation of this circle, the first part of the equation. This is the equation. This is how you find that equation there. So now, how do we sketch this? So I will draw my x y plane here. That's my y, and that's my x there. So I have a coordinate. It's 1 comma what comma 0. So if I say my 1 is here, 1 comma 0, so meaning I'm not moving anywhere in the y direction. So meaning my center is here, and I'm being told that the radius is 1. So meaning at any point I'm going to move. When I move up, when I move to the side, the distance will be what? Will be 1. So meaning if it was in this case here, if I move to this side, most definitely I will land where 2 is, because I have moved in a straight versus line. It's going to be what? Where 2 is, because it's a radius of 1. And here it will be what? It will be where 0 is, there where -1 is, and there where what? 1 is. So it's a sketch, guys. Sketch. So you just sketch like that. Okay, my sketch is not that good, but yeah. So you sketch like that. Okay, let me just erase this part here. I try to sketch nicely. So it's a tool I'm using. It's very hard to sketch, pardon me. Yeah, so here's my one. Okay, they say there. Yeah, yeah. Okay, you guys understand the concept of what I'm trying to say. So you sketch it like that. So that will be your axis. So distance from wherever point to wherever you go, your arrow will be what? Will be 1. From this point, the center, to whatever point, your arrow will be what? Will be 1. So we'll do the same with the next part of the question. So I will erase this part. I will erase everything here. Yeah, that I wrote before. Erase. Okay. Yes, you can ask. Okay, so no, like you must complete it. It's not that it's wrong, but you must complete it because you want the full equation of it. So just expand it. When you reach that point, you would have already identified that it's a circle and everything. Then you just what? Expand it till you have the entire equation. Especially to get full marks on it. Is that clear? Alright, thank you. So let's do the second part. Part B. So part B, so let's start with sketching this one. Let's start with sketching before we find the equation. Since I can I can sketch. Okay, let me do this. Okay, let me do this instead. Alright, using this part. Okay, so saying 1 comma 1. So if I have my 1 here in the y-axis, in the x-axis I mean, then in the y-axis, let's say my 1 is here. So meaning this here 1 comma 1 will be what? Will be my center. Then radius, we are moving what? 2 away from from it. So if I was to move in this straight line, like vertically coming down where 1 is, so I'll move from here to here, this will be 1. Then here on this point where that will be where this point where it's negative 1. So negative 1 here, where 1 comma negative 1 here will be part of what? Part of my circumference. Like, yeah. Then in here as well, when I move this side up to where negative 1 in the x is, will be part of the circumference. Yeah, it will just hit there on that base. Just trying to get those points, a few of them. Sorry, so 1 2 here, 1 2 1 2. From here 1 to 2, then you're going all the way up to what? 3. Let's say 3 is here. Right, so if 3 is there, meaning it will touch there as well. So where 3 is going to be. Then also here from 1 you move 2, then 3, like there, towards touch where that is. So you just make a rough sketch. As I said, my 2 is very hard to draw sketches, but yeah, you make, I know you make good sketches and these, yeah, like that. So on each point where you move from the center going to axis, it's going to be a radius of 2 as there. So as we've already identified that 1 comma 1 is our center, so that's our, we have our h as 1 and our k as well as 1. So I can write this x minus 1 squared plus y minus 1 is equal to 2 squared, squared there. Then I can what? Expand this. So when I expand this, I have x squared minus 2x, then I have plus 1 plus here I have y squared minus 2y, then I have plus 1 is equal to what? To 4. Yeah, so you can then write this in the form x squared, so x squared minus so plus, let me say plus y squared minus 2x minus 2y, then I have 1 plus 1 here. 1 plus 1 is going to be what? To be 2. But then here minus what? 4, when 4 comes the other side, or the reciprocal, the additive inverse. So it's going to be, so that will be 2, that will be minus 2 is equal to what? To 0. So you write it in this form. So remember, we said the general form of what? Of the equation is ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to what? 0. So this is the general form. So in this part of or in this question of the circle, we did not have everything. Like, it's not a must like everything will appear in your equation, but we have this form x squared, we have this y squared, we have the x alone with a variable, y alone with a with a, yeah, with a coefficient there, we have like that, and then we have a constant there, we have, and equal to what? To 0. So your aim when you're given this is to make something similar to what? To the general form of the equation. That's the reason why we have to expand completely like that. Yeah, so this is how you answer this question. Okay, so we move on to look at a different form of what? Of the question. So these are the different forms of a question that I'm talking about. So the question reads, for the following, show that it is an equation of a circle and find the center and radius. So as we've looked at the equation of what? Of a circle, the general form of how what? Of a circle, of how to find that, or how we identify it. So we must use that knowledge in order to what? To answer this question. So in the first part here, we see that we have x squared, then uh, 6x plus y squared plus 4y minus 12 is equal to what? To 0. So now we must get something that must look like this. So it must look like this. Plus y minus k squared is equal to some r squared there. So we must get something that is like this from these two equations here. So how do we get that? Let's start with the first one. So part A, have x squared minus 6x plus y squared plus 4y minus 12 is equal to what? To 0. So how we get that is we are going to factorize. So if you can see the first part here, this part here, we can group those and we can group the second part as well, and we can factorize that. So we factorize that using what? By completing the what? Square on them. So I have x and minus I have x squared minus 6x. So how do I complete the square there? I know you guys know how to complete the square, where we will say get x there minus, since this part here has a negative sign there, then half of this, you have this x, half of that is 3, so that will be 3, then that squared, then minus half of that squared. So what is half of so this is going to be minus, saying minus half of 6, which is 3. 3 what? 3 squared. So when we square 3, we'll get what? 9. So that's how we factorize the first part. Then the second part, how we do it, so this will be plus, we have y there, so y, then the sign that it's carrying there is positive, so positive will come there. Half of that is 2, then squared there, then minus, so what is 2 squared? 2 squared is going to give us 4. Then I have okay, then I have minus 12 is equal to what? To 0. Okay, then in this part now, the next thing that I do is I just add this. So what do I get when I add negative 9, negative 4, and negative 12? What do I get? Yes, what do I get? Negative what? Okay, negative 25. Alright, so I'll have negative 25. But I know I can move that negative 25 to the what? To the other side, right? Then it becomes positive what? 25. So that will be equal to 25, like that. So that is the general what? Or this from here, I can identify from here. I have x minus 3 squared plus y plus 2 squared, like that in the brackets, then is equal to what? 25. So I can be able to identify from that this is similar to what? To the general form, which is this there. I have that squared and that there, and my r squared is what is here. So meaning this here is the r what? R squared, which is, if you are to find your radius there, what you just do to find your radius, of which we're even asked to find the radius, which is the other part they're asking for. First to find the center. So let's even find that. How do we find the center now? So how we find the center is you equate this part here, this inside here, to 0, and also this inside here to what? To 0, such that you get those coordinates. So when I equate the first part to 0 here, I have x is equal to what? To 3. So meaning my center, my x coordinate is going to be 3. And then here when I equate to 0, my y coordinate is going to give me negative what? Negative 2 there, like that. So this is my center. Then how do I get my radius? So I see in here it's r squared. So in short, r squared is what is equal to what? To 25. So how do I do that? I put it in the root like that. So my r, my radius is 5 in this what? In this case. So this is how you solve that equation or that question here, the first part. So for the following, as I said, we've learned how to identify it here, and we have found the center and the radius. Are there any questions here? Okay, there is silence. Alright, so I will erase this part such that we do part B of what of the question. Then we will call it a day for this lesson that we are having. Alright, so how do we do that second part? So we follow the same procedure. So I have my x squared plus y squared here minus 6x plus 2y minus 17 is equal to what? To 0. And I can tell that this is going to give me a conic section, because from the general form I have a squared there, squared, I have this minus what, so I know how to identify that, and I know that it will give me a conic section. But which one? So we have to show that this is going to give us what? One for a circle. So I will group first of all my x. I'll group those that have x's. So x will go with 6 minus 6x. Then I have plus y squared plus 2y minus 17 is equal to what? To 0. Then I'll complete the square on the x's and on the y's. So on the x's here I'll get x minus half of that is 3 squared, then minus that's going to give me 3 squared is going to give me what? 9. Then plus y minus plus, in this case plus, because there's a plus sign there. That half of that is 1. Half of 2 is 1 squared. Then minus 1 squared is going to give us 1. Then minus 17 is equal to what? To 0. What do we get when we add negative 9, negative 1 and negative 17? What do we get? Alright, negative 27. So that's going to be minus negative 27. So now I can move the 27 to the other side, which will give me something like this. So I have identified that, oh, this looks like this. This is the general form of the circle as we have looked at. So it will give me, most definitely, this is a circle. And then I find now the center. So the center, I'll equate this to what? To 0. Then I'll have x is equal to what? To 3. I equate this to 0. Then I have y is equal to what? Negative 1. Then my center, which implies that my center is 3 comma negative 1. Then my radius, I just put that in the root there. So r root 27 is going to be what? My radius. And you'll be done with what? This question. Yeah, and you've identified, in this case, your center and your radius. Okay, so yes, yes, it's okay. So yeah, so that's okay. You can leave it as 3 root 3, which means the other part, it's still the same thing. Yeah. Is there any other question on this? Alright, so this is the first part where we've looked at the circle, and this is what you just have to know about the circle. So in the tutorial sheets or what is to come, Mostly they won't teach you about this, but you have to first understand the circle before you look at other things. So in the next class, we're going to look at the second versus part, where we look at the parabola. We look at the parabola. So uh, if there's no question, this is where we end with this lesson here.